This is a video on how to calculate the volume of a solid of revolution. So what do I mean by a solid of revolution? Well, let's imagine I have some function y equals f of x, and I'm going to plot it with my y-axis here and my x-axis sort of coming a little bit out at us this way. So you can imagine that's coming sort of out of the page at us a little bit. And let's say our function looks something like this. Now imagine we take a section of it. So let's pick 2 points on the x-axis. I'll call them A and B. And look at that area. So we've got some area here, some surface under that curve between those 2 points. Now imagine that I take that surface, that two-dimensional surface, and I create a three-dimensional object by rotating this whole thing around this line here, the x-axis. So imagine that the x-axis is like a pivot point or an axle, and this red surface rotates around that blue axis all the way around like this. And every point along that white curve will rotate around like that. So there'll be another one over here. And at every point along the white curve. And this rotation produces a three-dimensional object with some volume. And the question we're going to look at now is, what is that volume? Well, let's start with a very small piece of it. Let's say I pick a point on the x-axis, x0. So here's x, here's y. Let's pick a point x0. And let's say here's my function. Now imagine a very small region around x0. So let's say it goes from x0 up to somewhere else. And we'll say the width of this thing here is delta x. Now if you make delta x small enough, then your y value doesn't change very much from x0 up to x0 plus delta x. And so the volume of that little piece is going to be like the volume of a cylinder. A cylinder whose radius is y and whose thickness is delta x. So the thickness of this thing is delta x, and the radius is equal to y at that point, y of x0 in particular. And so the volume of that small disc, or that small cylinder, would be the volume of a cylinder is equal to pi r squared h, where h is the height. In this case, it's pi times y squared times delta x. And so to get the total volume, you could imagine you're adding up a lot of these little discs. And in the same way that when you integrate to get the area under a curve, you're adding up the areas of a lot of little rectangles, here you're adding up the volumes of a lot of little discs. And so it turns out that the actual total volume would be equal to the integral between a and b of pi y squared dx. So in the limit, delta x becomes dx, and by summing them all up, you're taking an integral. It's usually written like this: pi times the integral between a and b y squared dx. So let's look at an example. How about this example? Find the volume of the solid created by revolving the area under the function y is equal to 2x around the x-axis between x equal to 1 and x equal to 2. So a quick diagram. Here's x, here's y. Here's the function y is equal to 2x. And we're interested in that between the points x equal to 1 and x equal to 2. So here is my area, and we will revolve that area around the x-axis to create a three-dimensional thing which looks like a piece of a cone. And to get the volume, step 1 will be to get y squared. In this case, y squared is equal to 2x to b squared is equal to 4x squared. Step 2, get pi times the integral between a and b, y squared dx. So in this case, it's pi, a is 1, b is 2, y squared is 4x squared, and that's the integral we have to get our volume. So that's equal to pi times 4x squared. We increase the power by 1 and divide by the new power. And our limits are 1 and 2. So that's equal to pi times 4 over 3 times 2 cubed minus 4 over 3 times 1 cubed. And when you work that out, you get 29.32. So let's do a harder example. Another example. Find the volume of the solid obtained by rotating the function y is equal to e to the power of minus 4x plus 2 about the x-axis between x equal to minus 1 and x equal to 0.5. So this function, roughly, if we sketch it out, it looks like this, roughly speaking, and our points are minus 1 up to 0.5, so very, very roughly, something like that. So the first thing we're going to need is y squared. So that's e to the power of minus 4x plus 2 squared. So when we square that out, we'll get e to the power of minus 4x times e to the power of minus 4x. We'll get twice 2 times e to the power of minus 4x. And we have 2 times 2 at the end. So overall we get e to the power of minus 8x plus 4 e to the minus 4x plus 4. So to get the volume, we'll call it v. We have pi times the integral between minus 1 and 0.5 of y squared, which we know to be e to the minus 8x plus 4 e to the minus 4x plus 4 dx. So that is pi times the integral of y squared dx. And now we just have to integrate that. So we have pi times the integral of e to the power of minus 8x is minus 1 over 8 times e to the power of minus 8x. Then we have plus 4 times the integral of e to the power of minus 4x is minus 1 over 4 times e to the power of minus 4x, and the integral of 4 is 4x. And my limits are minus 1 and 0.5. So now I'll tidy this up a bit before I put in my limits. So that is minus e to the minus 8x over 8. That's just minus 1, 4 over 4. So I have minus e to the power of minus 4x plus 4x, and there's my limits. So now I can put in the limits. So I have pi times minus e to the power of minus 8 times 0.5 over 8 minus e to the power of minus 4 times 0.5 plus 4 times 0.5. And it's all that minus all that with minus 1. So minus e to the power of minus 8 times minus 1 over 8 minus e to the power of minus 4 times minus 1 plus 4 times minus 1. So that's equal to pi. There's another bracket there. Pi times minus e to the power of minus 4 over 8 minus e to the power of minus 2 plus 2 minus e to the power of 8 over 8 minus e to the power of 4 minus 4. So at this point now, I would go to my calculator. Well, actually, in fact, I would do one more thing. I'd sort out those minuses. Minus e to the minus 2 plus 2. So minus minus is a plus, e to the 8 over 8. Plus e to the power of 4. Plus 4. So at that point now, I would go to my calculator and get the following answer. 1360.56. So that's it. It's just a matter of squaring y and then integrating it between the 2 points you're given times pi. And that's all there is to it.